Hello, my name is Philip Totaro. I'm the founder and CEO of market research firm IntelStor. Welcome to your weekly dose of truth to power. Truth to Power examines data driven insights for the energy sector with a focus on renewables. On this week's episode, we'll showcase the latest operations and maintenance cost forecast and how OEMs, ISPs, and asset operators can determine how much they can expect to spend on component repairs. Well, IntelStor is quite proud to announce the completion of the industry's first and only comprehensive operations and maintenance cost forecasting tool. For those of you who use the IntelStor platform or you've been following us, you've seen us publish data on a blade repair forecast, including the fact that lightning damage has become the number one cost center for all repairs. While that still remains the case with blades leading the way on repair cost in the USA, the full turbine O&M cost breakdown shows how much the industry will spend on each component. In 2025, the industry is poised to spend more than $2.9 billion on wind turbine repairs in the USA. Blades contribute the most at 37% of the overall, and blades now total more than $1 billion in annual cost. Within that category, lightning damage is the largest single cost center with more than $255.7 million in repairs being undertaken in 2025. That is actually poised to escalate to more than 333 million by the end of 2034. Blade root failures are now the second most expensive repair for wind turbines with more than 222.3 million in annual costs. Root insert separation is a well-known issue on certain makes and models of turbines, and it's something that the industry has been dealing with now for a number of years. Pitch bearing repairs are the next most expensive category with more than 190.9 million in annual expenditure. Despite the fact that up tower repairs can be made with segmented components, some machines do not have a craneless solution for certain types of repairs, particularly when a full bearing swap is required. Now, making pitch bearing repairs as well as yaw bearing or any gearbox and generator repairs fully in situ is actually one of IntelStor's top 30 onshore wind technology trends. Speaking of generators, the consistency of bearing failures being brought about in part by stray currents has resulted in this category of repairs escalating costs to a total of 190.6 million. Yaw bearing repairs, including the slewing ring replacements, constitute more than 10% of the total annual repair costs. As I noted before, the need for a full crane callout to lift the nacelle to perform repairs or remove bearings to the ground continues to make those types of turbine repairs expensive overall, and the yaw systems in particular. I'm actually excited to note that this is a topic we will be discussing in just 2 weeks at the Wind Summit event in Houston, Texas, complete with the presentation by Soren Kellenberger from CNC Onsite. CNC Onsite's already developed technology for undertaking precision machining for yaw system repairs up tower. And the best part about that is that it can be done in situ, avoiding the expense of the crane callout. That's critical to getting these overall costs reduced in the future. Now, it's interesting to note that turbines with a nameplate capacity of between 1 and 2 megawatts are no longer the largest contributor to overall repair cost breakdown. Turbines which are 2 to 3 megawatts are now 52.5% of the total annual expenditure. Turbines in the 1 to 2 megawatt class are only 33.1%, with a smattering of 3, 4, 5, and 6 units coming online and making up the rest of that 100%. However, it's also fascinating to note that for turbines which are in the 1 to 2 megawatt category, lightning damage is the number one issue. But looking at the 2 to 3 megawatt class, they have actually incurred more annual cost from fatigue failure in the root as a larger chunk of the overall blade repair cost than lightning damage based on the data that we've got for the 2025 installed base. And while we expect lightning damage to overtake root issues in the coming years in the 2 to 3 megawatt class, this still underscores how impactful any repairs which necessitate significant downtime or require a crane call out can be for an asset owner. As I noted, these topics and much more will actually be discussed by a panel of experts at the Wind Summit event in Houston in just 2 weeks' time. Now, I think it's important to also note that this forecast for annual repairs was created by obtaining a breakdown of failure modes on all the different components, including failure rates, downtime, technician headcount per type of repair, labor rates, materials and spare parts cost, crane costs as necessary, as well as repair times, which include turbines that have or don't have service lifts installed. The forecast capacity additions, including officially published project pipelines from IntelStor, were used to determine the total addressable market. So, if you would like a demonstration or more information about this, please contact us at intelstor.com or reach out to me personally on LinkedIn. Thank you for joining me this week. I'm Philip Totaro, and this has been your weekly dose of truth to power. Follow us on IntelStor's YouTube channel as well as your favorite audio platforms, and visit www.intelstor.com to join more than 200,000 subscribers to our renewable energy data solutions. A full analysis of the renewable energy market in the USA is available to subscribers, as well as this new forecasting tool. And you need to register today for the next Wind Summit event in Houston, Texas, in just 2 weeks. Visit www.windsummit.org and join hundreds of your industry colleagues from companies like NextEra, EDPR, EDF, Pattern Energy, Clearway, Apex Clean Energy, and more. We hope to see you there.